Problem number 3, we've got two lists of numbers, the miles per gallon. So it says average miles per gallon M. That depends on the speed at which the given car is traveling. And so that speed is going to be our L1. Those are our X values. And then our miles per gallon, that's going to be our list 2. Those are our Y values. So Y is dependent upon X, the speed being the independent variable, the miles per gallon being the dependent variable, and we know how to type that in. We go to stat, and then edit is already selected, so we hit enter. And if we already have numbers in our data in our table, we're going to highlight the name of the list. So I move my left arrow and then my up arrow to highlight the name of the list. Then I hit clear, enter, and that clears the list. I do the same for list 2. I like to do this instead of trying to count how many there are. I could just type right over them, but if I have more data in my current table than my table that was on my calculator, I could just type over it. But I really prefer to start with a clear list 1 and a clear list 2. So we're going to go ahead and type those numbers in, and I'll pause the video while I'm doing that. So I suggest you do the same, and because I'm going to pick up as soon as I type all these numbers in. So now that I have all the numbers in my data table, I'm going to go ahead and push y equals, clear the function that might already be in there, which I had one. I'm going to hit my up arrow, select plot 1, and then move my cursor off of plot 1 to make sure it's there, selected. And then I'm going to hit zoom 9 for zoom stat. And I can see that the data does not look linear, and it's not asking me to come up with anything but a quadratic function of best fit. So I'm going to go ahead and do that. And to calculate our quadratic function of best fit, I hit stat and then right arrow for calc, and then we know we go ahead and highlight quad reg, or we can type a 5 as well, enter. And then we're going to want to store this in y1 just like we do. Vars y variables, right arrow, enter for function mode, enter for y1. It shows y1 there, so we hit enter to go down to calculate, and now enter to actually calculate our quadratic regression model. And then we just write that down. It's asking us to do that. What is the quadratic function of best fit? So therefore we write it down. So our parameters A, B, and C, we write them down. So we're going to round each of our parameters to 3 digits after the decimal. So we have y equals negative 0.006x squared. That's our A. And then the B and the C are both positive. So we have plus 0.720. We don't have to write the 0. X. And then plus C, which is 5.143. Careful that you round to the nearest 3 digits after the decimal. Don't worry about that r squared on my screen for now. And then, so we've got that. What is the quadratic function of best fit? Check. And then round values to the nearest 3 digits after the decimal. Did that. Check. Always read the directions. According to the quadratic model, what 2 speeds would yield an average miles per gallon of 21 miles per gallon? So we are going to use our model. So it should be, our 2 speeds should be somewhere in between 30 and 40. And then when it comes back down, it's going to be somewhere above 80. So we're going to probably have speeds somewhere in there and somewhere in here, depending on what our model says and gives to us. So there's our model. But what we're trying to find here is we're actually trying to solve this equation here that average miles per gallon of 21, that's our y value. So we are actually solving this equation. And when we solve this equation, we're not plugging in anything for x. We're trying to find out x equals what, because we don't know what that speed is and we don't know what that speed is. So if we're trying to find the speed, this is our y2 value then, and this guy already is our y1 value. So let's go ahead and type in y2 as 21. So we want to figure out, again, the speeds that would yield the 21 miles per gallon. And then we'd graph. So we can see clearly that 21 is the red graph. Our quadratic model is the blue, and we want to calculate the points of intersection and find the x values, which represent the speeds. So if we do second trace intersect 5, enter, we select our first curve. Notice at the top of the screen it says y1, so the cursor is already on our y1. That's one of the curves we want to find the intersection points for. So I mark that with an enter, and then notice that the cursor automatically toggles over to the y2 equals 21. Enter to select that. Now I'm just going to move the cursor over to the left intersection point first, and then I'll do this again and move the cursor over to the right intersection point for my guess. And I hit enter, and it gives me 29.792. So y then or x equals 29. What did I say? 792. And then we also have, let's do it again, second trace intersect. I'm going to just type a 5 now, and it's asking me for the first curve. Enter, second curve, enter. But now, if I hit enter again without moving my cursor over, it would give me the same point. So I'm going to move my cursor closer to the other one, and here I get 84.359. 84.359. And so, therefore, what two speeds? 29.792 miles per gallon, and 84.359 miles per gallon, which, if you remember what we estimated before, we said, oh, okay, 29.7, so it's a little bit under what we estimated, but this one's right on track. But again, we're using the model according to the quadratic model. We're not using the data. The data yield the model, and the model yields these numbers here. And so those are the two speeds which would yield an average miles per gallon of 21 miles per gallon. So there we go.